All right, so let's see. Write an equation of the function g of x that is the graph of f of x equal to, which is equal to absolute value of x, but shifted left 3 units and down 6 units. So this is testing our knowledge of transformations. So the first thing I want to underline here is that our original graph is going to be shifted to the left 3 units. So what does that mean? That means that we're taking our x, here's our setup, x plus 3, and you remember from the general formula for shifting left to right, you just take your setup, x plus whatever your constant is, in this case is 3, and you set it equal to 0. And when you solve for x, I get x equal to negative 3. The negative sign indicates that this graph is shifting to the left. Okay. And then the 3 means that it's shifting to the left 3 units. So when you look at g of x, all right, the original function was, it started off as absolute value of x, but in this case, because I'm shifting it to the left, I'm going to have x plus 3. All right. So now the next thing I want to do is look at this thing being shifted down 6 units. So this is just, we're just going to be subtracting 6 on the outside, just like this. All right, so let's try to look at this from a graphical perspective. So if I take my original function, which is f of x equal to the absolute value of x, that looks like this. When you have graphs, whenever there's an absolute value in your function graphically, it's going to have this V type shape. But looking at g of x, that's just taking this V and we're going to shift it to the left and then down 6 units. So I can pick any point on this graph, and easiest thing is to use the vertex. So this is 0, 0 right here, the vertex. So I'm going to move to the left 3 spaces. 1, 2, 3, and let's see, go down 6 units. 1, 2, 3, 4, 5, 6. So here's our new vertex. All right. And I'm just going to pick, let's see, I can pick a couple points on either side of our vertex. So I'll pick, let's see, what is this, -1. I'll say, let's pick -1 and see what we get for -1. Absolute value of -1 plus 3 and minus 6. So the result is, let's see, 2 minus 6, and I end up with -4. So if I plug in a -1, I get a 1, 2, 3, 4, get a -4. And then I'll go this direction to make it symmetric. So let's see, if this was negative, this is -3. It's -1. Let's see, this would be -5. So what am I going to get if I plug in -5? G of -5 is equal to I get a 2 minus 6, which is equal to -4. Comes here. It's -4. And so I have my vertex and a point on either side, so I end up with something like this. Okay. And just to kind of point out, I know I went and just I started with the original vertex and just counted the units, counted to the left 3 units and down 6, but based on our our function g of x here, if I take, let's see, our vertex is -3 comma -6, just to verify that this is, like, I moved it the correct spaces and we have the correct function. If I take g of -3, this is telling me I should end up with a -6 based on our function. So -3 plus +3 minus 6. This is what, 0. Absolute value of 0 is just 0, so I end up with -6. So yes, verify graphically and by plugging in a couple points that we have the correct transformation here.